How's it going, Geometry Cats? Today we are looking at 11.1 space figures and cross sections. So we're going to be going to space and cutting stuff in half. That's not actually what's going to happen. First, let's talk about three-dimensional figures. We're moving from the paper world to the real world, right? I got a roll of coins here. I was counting the change. Okay. In a three-dimensional figure, a polyhedron, a prism, a pyramid, you have three things to look for. You have faces, those are your flat surfaces. You have your edges, those are your corners. Not your corners, but in your wall, where your walls connect. And you have vertices, which are your points. Okay? Let's take a look at this guy. We're looking at this polyhedron. Polyhedron is a three-dimensional figure made of polygonal faces. It means each face is a polygon. Polyhedron. Okay. Here, how many vertices? So let's do vertices first. So vertices, we have R, S, T, U, V, W. R, S, T, U, V, W. How many edges? Well, we have RS, UT, TS, are you listening? VR, virtual reality. SW, Southwest. UV rays. TUW, I got nothing. And WV. See, I have to mark them, guys. If I don't mark them, I lose track. So I'll try to give you a worksheet on this so you can actually mark it up. And last we are faces. Well, we have RUT or RUST, rust. We have STW. We have TUVW. We have RUV, RUV. And we have SRWV, right? Why is TV not an edge? Well, because something you watch in your house. Well, because they aren't connected in the polygon. I'm not even going to write that. That's ridiculous. Why did they put that question on there? They're fools. Okay. Let's talk about Euler's formula. Not Euler. It's Euler. Say it with me. Euler. Euler. Yeah. What his formula says, and it's true, it's not a theorem, it's a formula. Your faces plus vertices equal your edges plus 2. I'm going to show you something. Take a look at this. So faces plus vertices equal edges plus 2. Whoa, slow down there, buddy. Let's take a look at this three-dimensional figure. Look at this guy. Okay. 7 faces, 10 vertices, 15 edges. 7 plus 10 equals 15 plus 2. Like this, because it even has a... It shows you the net when you break it apart. Now I want you to know something. When they open that up, they're all polygons, right? Yeah. So again, 10 plus 16 is 26. Equals 24 plus 2. This is actually a really neat website. I have one for... Here it is. Ready to apply? Yeah. So let's take a look at connected pyramids. Well, how many faces do we have? No, let's not do that. Let's take a look at polygonal pyramid. Well, I have 1, 2, 3, 4, 1, 2, 3, 4, 5, 6, 7 faces, right? Why do I have to check my answer? Check your answer in the previous box. Is there a check answer? Alright, let's just do this one. I had to do some fancy editing, guys, so we're going to start back. So Euler's theorem, let's try it. Triangle pyramid, look over there. We have 1, 2, 3, 4 faces, right? Let's see how many vertices we have. Okay, we have 1, 2, 3, 4 vertices. So for edges, I don't even need to count them because I have 4 plus 4 is 8 minus 2, 6. Good. Okay, let's get back to the lesson. I got sidetracked. Okay. Oh my goodness, Mr. Twilliger, how am I going to count all this up? Well, think about this. My faces plus my vertices equal my edges plus 2. So f plus 20 equals 32. So f equals 12. Again, my faces plus vertices equal my edges plus 2. So 32 equals my edges plus 2. 30 equals my edges. Okay? Okay. How can I verify? Look at the right. Well, how many faces do I have? 1, 2, 3, 4, 5, 6. So I have 6 faces. How many vertices? See, I have 1, 2, 3, 4. No, Mr. Twilliger, you're counting vertices. That's edges. 1, 2, 3, 4, 5, 6, 7, 8. 8 vertices. And how many edges do I have? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So I have 12 edges plus my 2. So I get 14 equals 14, so it works. Now I have to draw a net for the salad. For the solid. Let's go back to this website. That's what a net looks like. Okay? And you see how like you can fold it back up and you can get that shape. So that's what we have to do. Okay. So I'm going to start with my trapezoid. Okay? Now that trapezoid is connected by a rectangle. This is the bottom that we're looking at. To another trapezoid. Okay? Then I have a medium rectangle. Medium rectangle. You have a little rectangle. So that's my net. Can we verify Euler's with your two-dimensional net? Yeah. I'm not a fan of it. I'm going to be honest with you guys. So we're going. Cross sections. Cross sections are you have something, you cut it. Okay. Hold on a second. Let's say I have this cheese stick, right? And we're gonna say it's a cylinder. Okay. The question you might be asked is, if I make a cross section diagonally, see how we're making a cross section, we're cutting it, what shape will that make? Well, on a cheese stick it makes an oval. Okay. They might ask you, if they take a cross section down the middle like this, what shape would it make? And to get those, you just look at, it's going to be a rectangle, right? If you don't believe me, don't try this at home. Okay. If we make a cross section, we have a rectangle. Quite a delicious experiment. What am I supposed to do with this now? In a pyramid, my cross section is a triangle, right? Alright, here we have a figure that's made with a bigger circle. Down here you have a smaller circle. If we made a horizontal plane, what kind of shape would we make? Well, you'd make another circle. The next one's the tough one. I gotta eat the cheese now, guys. I'm not gonna waste it. If we draw a vertical plane and we cut this guy in half, what shape do we make? Well, look at. What kind of shape is that? It's a trapezoid. Trapezoid. Okay, I got through this one. I love cheese. Let's try again. Draw a cross section formed by a vertical plane intersecting the front and right faces of the cube. Oh, mamma mia. So front and right, right? Here's your front, here's your right. Okay? We're making a cross section. 1 second. Okay, so here's my front, here's my right. So I'm going to take my knife, I'm going to start here, I'm going to cut until I hit the right. What kind of figure is that? It's going to be a rectangle. Okay? These are tough, guys. You gotta visualize them, be a good drawer. I'll help you out with them. Enjoy.